Hello, and welcome to the overview of the Running Rollator MSD project. My name is Luke Galvin. I'm an industrial engineering major, and I'm the project manager for the current project.
My name is Connor Donahue. I'm a mechanical engineer and the communicator for this project.
My name is Daniel Gaviria. I'm also a mechanical engineer, and I am the systems engineer for this project.
My name is Ethan Giacomelli. I'm also a mechanical engineer, and I'm the facilitator for this project.
And my name is Quinn Vilwalk. I'm a mechanical engineering major, and my role is purchasing for this project. So the problem that we are trying to address is the lack of a lightweight, collapsible, and adjustable rollator in the current market. This product would be used by people with limited mobility to move more freely, allowing for a more active lifestyle and the chance to be able to move on park trails and outdoor environments. As stated previously, the rollator has to be lightweight, ideally less than 50 pounds, collapsible, and have the ability to adjust to accommodate to the heights of users between 5 and 6 feet. The rollator also must be able to maneuver over a 1-foot surface transition in order to travel over roots or rough terrain when in use. Another goal of this was to evaluate last year's prototype and make adjustments and improvements to better fulfill the necessary engineering and customer requirements.
In evaluating the prior prototype, we made stark design changes, mainly in transition from rectangular frame shape to a more triangular frame style. As the previous prototype required higher effort and difficulty to execute turning, we decided to implement a fork-based steering using a rotary feedback control rather than a typical bike steering control. For user comfortability, we took a similar approach to the prior group in utilizing armrests as well as additional support with adjustable chest rests. Our team was able to use design thinking principles and brainstorming methods to eventually agree upon an initial design. An initial CAD design of our prototype can be seen in the center image, and the PVC mock-up can be seen on the right. We based our design on the frame runner, which is used in the Paralympics for track events, as seen on the left. Once the CAD model was finalized, FEA analysis on different components were conducted to validate our design.
So here you can see the two different FEA analysis for some of our components. On the left, you can see the FEA analysis for the steering system that Ethan previously mentioned, and on the right is the FEA analysis from the frame as a whole. The FEA analysis for the steering system was done on ANSYS, and the frame was done using Creo Parametrics built-in FEA analysis tool. And from both of the analyses, you can see that the deflection and the stress are all under the ultimate stress for aluminum 6061, which is our chosen material due to its lightweight properties and also good strength. So with this FEA analysis, we can validate our design and use this information to move forward with our manufacturing.
So the final 3D model can be seen on the image to the left. A user can rest their weight on the handlebars of the steering system as well as the chest support. The steering system can be adjusted to fit the needs of the user using 2 rods on both sides of the steering system. And for easy transportation, the rollator can be collapsed using a mechanism on the front drive shaft, which helps to fold in the 2 sides of the frame on itself. The braking system includes the braking of all 3 wheels by the pull of 1 lever, accessible from both of the handlebars. The final prototype of the rollator is currently still in progress of being manufactured and will be revealed at Imagine RIT. We also plan on conducting user testing on the rollator once it is fully manufactured to determine if our target market is comfortable with using said product. Currently, we are working with the disability organization and clubs at RIT to obtain people for user testing and to help us determine areas of improvement.
So some issues that we addressed during the MSD process. The initial prototyping, as seen previously, we conducted our prototyping using PVC to get a general shape of the rollator. And from this prototype, we determined that the frame was going to be way too long, the total length of 8.5 feet. And we realized this would be much too heavy and difficult to transport for the user. So we fundamentally changed our design to make the frame much smaller, now with an overall length of around 6 feet. Secondly, the collapsibility mechanism. The design had to be changed multiple times during the design phase. This caused some delays in scheduling, but eventually a final design was decided and we were able to manufacture. and we're able to achieve our desired collapsibility within the given time frame. And lastly, adjustability. When creating the design for the rollator, the height adjustability was a bit of an afterthought. When we were trying to implement the adjustability, multiple design changes had to be made, which caused a slight deviation from our initial design, especially the steering system. However, eventually we were able to reach a balance between the height adjustability and our original design that would be feasible and comfortable for the end user.
We would like to acknowledge some different people who helped us throughout our MSD project. Firstly, Jameson Pleasant, our client, who has been very helpful during the project, giving us an initial concept idea and then meeting with us throughout the both semesters to work through our different design challenges, as well as consolidating to a much more clear final design. We'd also like to thank Oliver Miller, our guide for this project. He has been great with giving general advice during the design and manufacturing of the rollator, as well as helping with any other general issues and providing some great examples of different products that assimilate our rollator. We'd also like to thank Elizabeth Bartle and Catherine Fisher from the MSD office. They've been crucial to giving us structure during this project design, helping us resolve any issues, as well as making sure we're keeping our finances in check and helping us with the purchasing of different materials. We'd also like to thank Matt Marshall, the biomedical subject matter expert, for his input in a biomedical perspective for this design, giving us advice on the adjustment of the rollator and how to provide best comfort for the end user. And finally, we'd like to thank Gary Houdinius from the machine shop. He has been crucial in our manufacturing process, helping us with the welding of aluminum, which is a very difficult process, as well as giving us many different suppliers that can help us with our materials.
Thank you all very much.